So we're going to find the derivative of f of x. And shortly, in just a few more classes, we'll be learning something called the quotient rule. And quotient rule would certainly be an option to use here. But even once you know how to use the quotient rule, you don't always want to use the quotient rule because it's not always going to be what's the easiest. So what I would recommend for this question, and really our only option here, is to use what we know about fractions and split this up. So it's like this part of the numerator over the denominator, and then this part of the numerator over the denominator. So you're used to normally subtracting fractions, so you're used to going this direction, but it's certainly fine to go that direction. That's what's going to be helpful here. Now, if I do that, I can use properties of exponents here and say this x to the third could cancel out an x to the third here, which would leave 2x. And this x could cancel out one of those, which would leave 1 over x squared. And I want to make one more quick little rewrite so that I can use the power rule twice. So x to the positive 2 in the denominator is the same thing as x to the negative 2 in the numerator. Now, up here, I'm ready to find the derivative. So I can find the derivative of this and then minus the derivative of that. Derivatives work that way where we can do them one term at a time. Okay, so the power rule here, this is a 1. So if I bring the power down, 2 times 1 is 2. And then if I lower the power by 1, x to the 0 is just 1. So anything to the 0 power is 1, but we don't need to write that. So the derivative of 2x is just going to be 2. Now if I bring the power down here and lower the power by 1, that looks like that. So there is our derivative. The only cleanup I would suggest is negative exponent is considered unsimplified. So x to the negative 3 in the numerator is like x to the positive 3 in the denominator. I would stop there.